I think there is a lot that we can learn from evolution, both genetic, epigenetic, social, as well as cultural. I strongly believe in that. I mean, that's could be controversial, but here I am. Hey, I'm Arna. I'm going to answer the impossible questions. I generally work on neuroscience-inspired artificial intelligence, and the work I'm presenting at this conference is more about how we can draw insights from how we learn, like humans learn, so the real brain learns, to accelerate learning in artificial neural networks, specifically for self-supervised learning. The question is, what combination of existing tech plus new developments will take for us to run billion parameter architectures on edge devices? I think right now we are using a very energy intensive and dense parameterized models. I think if you look at real brains, they're much more sparse, way more energy efficient. So I think what we need is existing tech in terms of like training large models, but on the inference side, we need to take inspiration from how the brain does floating point operations to do much better, like much more efficient, both compute as well as energy efficient inference on edge devices. Will xLSTMs be the future of NLP? I'm not an expert of NLP, so I'm gonna give it a wing. I think so. Yeah. I mean, we need to have more alternative architectures, because attention is one way to get at a solution. But I do feel that there are existing architectures that have some other implicit biases that might help in some tasks, if not all tasks. So we might not have xLSTMs as the architecture that solves all tasks, but I do feel that there is scope there. Why are foundation models dramatically less energy efficient learners than human brains? We have not incorporated anything that from evolution in our foundation models yet. Brains do not start from scratch. We do not learn as humans starting from scratch. We learn something that is almost evolutionarily derived, good starting points. I think there is a lot that we can learn from evolution, both genetic, epigenetic, social, as well as cultural. And I think if we can incorporate some of those starting points, the energy efficiency, both in terms of like both energy as well as like sample efficiency, will improve. I strongly believe in that. I mean, that's could be controversial, but here I am. What's the belief about model training that you have held on to for years but are starting to question? It seems related, but I really think that everybody who pre-trains models, I think we're reinventing the wheel from scratch. And I think that has been the go-to way to kind of train models historically, and by history, I mean the last 10 years. I think our field is moving to a point where we do not need to reinvent the wheel. We can probably use existing generation of models as good starting points. And starting from scratch will not be in the next 10 years, starting from scratch is not like the random initialization will not be the go-to initialization anymore. I do think that continual pre-training or continual learning will make large strides in the recent future, and that will drastically change model pre-training. I do think that is a big difference in terms of like how we initialize our models. I do not think the way we initialize our models right now is the best way to initialize them. The question is, catastrophic forgetting is a major challenge in developing neural networks capable of lifelong learning. What breakthrough do you think is necessary to overcome this issue? Is a completely new approach required to make continual learning practical? I think catastrophic forgetting or continual learning is definitely an issue, but I think most of these issues happen because we train networks using stochastic gradient descent. A lot of these optimization methods that leverage noise in the sampling does lead to something called stochastic collapse, where the model finds certain simpler solutions or simpler subspaces where they're trying to learn generalizable solutions better. What that also leads to is a reduced capacity of the model to learn from new data. And I think trying to keep a more cognizant notice of like what is the span of the model representations or model weights, I think will change how we think about the definitions of catastrophic forgetting or loss of plasticity that we currently think about in the field.